Okay, worksheet 18. As you work with the programs, things are going to start getting easier and easier the more of it you do. So, how many times should a standard output with a specific address appear in the program section? Or specifically, like, how many times should I have Y1 as an output? And I hope you all realize by now only one time. And then if somebody does put one in more than once, which is question 2, how will the PLC interpret it? And based on the way a PLC scans, it's going to interpret only the last one. So if you've got it more than once, you might as well take the first one out, because the PLC is only going to determine its on-off based on the second one. So if you've got a lot of logic to control one output, you've got to OR it, or you've got to put things in parallel. The same thing as an OR. What programming instruction is the exception to number 1 and 2 that you know of? When you use a set, you will need a reset. So that is the exception. What happens during a full program cycle? Okay, at some point I will do forces. Full program cycle. Step 1. PLC scans its inputs to see which condition it's in, or see what condition they are in. Step 2, if there are any input forces, it will update those inputs based on the forces, or overrides is what Click calls them. Once it has the inputs and the forces updated, step 3 is it will execute the logic based on the inputs. And it will determine the outputs of the logic. That's step 3. On step 4, it will then take any overrides or forces you have on the outputs, and it will go ahead and apply them to put those outputs in the condition of the override, whether on or off. So that's step 4. And then step 5, it will update its outputs. That's what happens during a full program cycle. There's 5 steps. Once it updates its outputs, it goes around and starts back on step 1. It goes back around and checks its inputs. And when your scan cycle is like 7 milliseconds, this is happening every 7 thousandths of a second. It's doing all 5 steps. So it's just incredibly fast. What controls whether a PLC will run its program? I think you've got a run stop switch on there. And you can put it in stop, it won't run. You can put it in run, it runs. You can also remotely control it with the software. You can put it in stop remotely. You don't have to flip that switch. The software, if you're online, you can also do it that way. All PLCs have this in some feature, have this feature in some form. Allen Bradley has a key switch that you can key to different positions. I think Siemens actually got away with the key switch, but they still allow you to put it in program or run, or I don't know what their other states are, but only one of them will run its program. In testing and verifying your timing and counting programs, what can you do to the accumulated values to expedite that process? I hope everybody has used DataView by now, and you can go in and put in the value for the accumulated value of a timer, and you can write a new value to the PLC while it's running. And you can get to the end of your count or your timing a little quicker that way. I used to use that very early on. That's how we would get the presses to actually step through their steps. They had a time in each step, and we'd go in there and we'd change the accumulated time value in the step, and that would make it step to its next step. and then so forth and so on. That was that I think that remains in my mind the best way to change a program. Yes, you can go in and force things and do all sorts of stuff, but if you've got a logical process going and you're just waiting for a timer to time out, then just change its value to something near its finish point, and then your program will do its next step. All right. Man, I talked that one to death. Revisit, reload, or rewrite your motor forward, stop, start, forward, reverse. Control the motors with input forces only. So I'm wanting you to go in there and do some overriding of inputs to see if you can turn both motors on with only input forces. So if you do it right, you should not be able to do both motors on with input forces. And then control the motors with output forces only. And what you should see is that with an output force, you can, in fact, energize both those outputs, even though you should have an interlock in your program to prevent both outputs from being on at the same time. So that'll really hopefully drive home the point that output forces ignore the logic, but input forces still have the logic in order to maintain some degree of safety. Okay, what does the click copy output do? What is similar in Allen Bradley? In Allen Bradley, they have a move statement. It's a very powerful statement. In the click, they have the copy statement, which is similar to Allen Bradley's move, but it actually has an extra step that you don't have to do in Allen Bradley, that you do have to in click. Sorry. I did make a couple videos on the output, on the copy command, so you can see it actually in a program, and you can pause the video and implement it in yours, etc. Mask. In Allen Bradley, you can write a word, which is 16 bits, to a word, an output. 16 bits. So it's setting aside 16 bits that it's writing when you move stuff in Allen Bradley. So for instance, in our click PLC, we only have 6 outputs that really matter, Y1 to Y6. So if we move Y1 to Y, whatever the 16th one would be, we're only in the real world controlling 6 real world outputs, even though we have that whole word. So what a mask does is it allows you to go in and tell the Allen Bradley move statement to only control certain outputs if it's a smaller subset than all 16 in the word. That's what a mask does. Click sort of has that functionality because you have to do 2 steps. If you want to write to certain outputs, then you have to map them. You have to map them from point to point. So you can sort of do a mask that way. It's not as easy as what's happening in Allen Bradley, but you can sort of do it. From a logical standpoint in a digital class, what the mask does is it ANDs your outputs. So whatever you're moving, the mask is either going to AND a 1 with it or AND a 0 with it. If it ANDs a 0 with it, it doesn't happen. If it ANDs a 1 with it, it lets it through. So you're just setting the mask based on 1s and 0s as to whether or not you want that particular output to get through. That's what's happening logically when you got a mask. It's a good thing probably to watch a video on or whatever. In the advanced class, you will have an opportunity. I don't know if making you write programs with move statements is the right terminology, but you may have the opportunity to actually see the mask work. What mask would be used with a copy or move statement to not affect other logic controlling bits 2, 4, and 5? So basically, we've got to ignore bits 2, 4, and 5. So 1, 3, and 6 would be on. So 1 is worth 1, 3 is worth 4, that's 5. 1, 3, and 6. So I'm thinking of the binary in my head. Yeah, 1, 2, 3, 4, 5, 6. So 1 and 3. So if I look at the binary numbers, I've got a 1, 2, 4. So 4 is 3. 4 would be 8. 5 would be 16. 6 would be 32. So my mask for those 6 bits, if I did not want to affect anything on 2, 4, 5, would be 32, which would be bit 6, bit 3, which is 4, and bit 1, which is 1. So it would be a mask of 37. And what that will effectively do is I'm moving everything, but I'm ignoring the logic being controlled elsewhere in my programs for bits 2, 4, and 5. Now, can the click copy instruction be masked? See unpack, copy, and help. You sort of can, because you can sort of pick the bits where you unpack it to, and you can map one to another. So you can sort of build in your mask in the program, and that's what we're doing. I want to go back to the top here. How many times should an output appear in a program? When you're moving, you're not addressing that output, particularly if you mask it out. So if you don't mask it out and you have something controlling, say, Y1, and then you're on down here doing a copy and you're copying to Y1, then you've got 2 things controlling Y1. And what we talked about up here at the beginning still applies. It's going to do the last thing it saw. So you got to get into the details a little bit. Nothing's hard. It's just there's a little more details to it that you got to keep straight. And mask really came about because it's such a powerful instruction, and it was so big, so many bits. And what the mask ultimately did is it allowed you to scale that down to say, oh, I'm only going to control 3 or 4 bits, not all 16. But as PLCs have advanced over the years, and you've got so much more memory and so much more power and so much more versatility, mask isn't as big an issue as it used to be. Okay, anyway. Worksheet 18. And I thank you for watching.